All right, hey everyone. Thank you for joining us for this session. My name is Trevor. This is Arthur. We're both engineers at LinkedIn on the orchestrators team. And today we're going to talk to you about the lessons we learned while migrating to Airflow at LinkedIn. So before we get into some of the lessons we've learned, I want to give you some background on data engineering at LinkedIn and kind of where our journey started. So for the data pipelines landscape, we run about 100,000 unique data pipelines for all kinds of different use cases, ETL, machine learning, ingestion, whatever. And all of these data pipelines integrate with a lot of different systems in our data ecosystem. So these could be anything from compute engines to analytics engines like Pinot. It runs the gambit. And historically, for the past decade or so, LinkedIn has used a tool called Azkaban to run these pipelines. For those of you who may not be familiar with Azkaban, Azkaban was an in-house built tool by LinkedIn, and it's also been open sourced by LinkedIn to meet all of our orchestration needs. And for some brief background kind of on how we had deployed Azkaban, we used a centralized cluster management, meaning that our team owned all the clusters, and users would just upload their DAGs and execute them. And we would federate as necessary based on use case if we needed to for scaling purposes. And I would say all said and done, we were running about 20 clusters in total for Azkaban. And to touch briefly on how job authoring or DAG authoring is done rather in Azkaban, Azkaban uses this job operator plugin concept. So these plugins are kind of similar to operators in Airflow, but a little bit different. And these were vended out as plugins. They were owned by the downstream team. So in the case of like Spark, for example, they would own this operator plugin, and it would be responsible for dispatching jobs into Spark. Users would then use these job operators within their DAG, same way they do in Airflow, mix and match, using a Groovy-based DSL. So why the interest in Airflow? So Airflow has a lot of great features, as everyone here pretty much already knows. It's very highly regarded in the industry. It has a lot of there's engineers with a lot of experience with it outside of LinkedIn, so that's a big plus. It also has a very rich feature set, and actually a number of the features that Airflow offers were actually features that we were planning to build into Azkaban anyway. So this was a very nice bonus for us, a very nice plus for Airflow. And also the strength of the community. So as you can see on the graphs on the right, this is kind of the commits into Airflow and Azkaban over time, ranging from 2020 to 2023. The graphs look kind of similar, but if you look at the y-axis there's actually like an order of magnitude difference in terms of commits. So this feature velocity was a really big selling point for us on Airflow. So given that, we decided that we were going to go ahead and evaluate Airflow for data pipelines at LinkedIn. This started in around 2023 timeframe. And as you can probably guess, because we're standing here, the feedback from our initial users was really positive. So given that, we decided that we were going to go ahead and really invest in Airflow as a first-class orchestrator within LinkedIn. Now, as we did this, we had a few design considerations that we kept in mind. From a practicality standpoint, we wanted to maintain this like centralized cluster management. This works really well for us at LinkedIn, and it gives us the right breakdown of responsibilities between our infrastructure teams and our DAG teams, or our data science teams. And we also wanted to preserve this job operator ecosystem that existed in Azkaban. All these are written in Java, and we didn't want to ask all these teams to rewrite them in Python. So we wanted to figure out a way we could sort of repurpose them instead of maintaining or forking or duplicating the code. And lastly, we were also taking into consideration how can we optimize the user experience and address a few pain points that we had in Azkaban. So for one example, we wanted to provide a single pane of glass for users and avoid any sort of cluster federation, which is what we had used to scale in Azkaban. This will ensure that our users can see all their DAGs, all their executions through a single pane of glass on a single UI, and avoid having to switch between different UIs, which was very annoying for some of our users. We also wanted to really improve the development iteration cycle. Azkaban required you to sort of upload your DAGs for testing purposes and running purposes, and it's really slow and cumbersome, especially if you're like not in the office. Uploads over public networks are very slow. So that could take minutes, sometimes up to 10 minutes, depending on how big the payload is you're trying to upload. So given all those considerations, this is the high-level architecture that we ended up with at LinkedIn. So on the left there, you can see we have a number of these DAG repos. These are owned by our data science teams or whoever's constructing the DAGs into Airflow. These can get deployed into our production Airflow cluster for execution. We provide them an upload plugin capability for this. We'll talk about that a little bit more later. And then these DAGs, when they run, they execute jobs through the job executor service. So this is kind of what I talked about before. This is how we're encapsulating those as command job operators. This service basically makes them API invocable, and we can reuse the exact same logic under the hood. So Airflow will invoke these, and then behind that is all of our compute engines, Spark, whatever other integrations there are into our data ecosystem. And then below our Airflow cluster, you can see we also provide an Airflow sandbox with the dotted lines. This is what's used for our testing. We provide an iterative testing capability using these Airflow sandboxes, which I will talk about some more in a couple slides. Okay, so now we have a new problem. Now that we've sort of integrated Airflow as a first-class orchestrator. Twice the orchestrators, twice the support. So just like the comic says for standards, the same is true for orchestrators, right? There is no perfect orchestrator. They all have their own pros and cons. Everyone has their preferences. Some people love as-command, some people love Airflow. But despite all of that, we decided that we were going to go ahead and consolidate all of our data pipelines onto Airflow. So this falls squarely into the easier said than done bucket, as we had to migrate 100,000 production pipelines from as-command to Airflow. And ultimately, this involved us translating 100,000 DAGs from Groovy to Python. We had to work with a bunch of teams at LinkedIn to update all their integrations with as-command and make sure the same thing. So like, for instance, API integrations are all working through Airflow as well. Any systems that were consuming events or metrics that as-command is producing had to start consuming them from Airflow as well. And we also needed to provide a very quick way to validate these converted pipelines, because as we convert the pipelines, we can't expect our users to spend hours or days verifying that the pipelines work. So we needed a quick way to do this validation. And if that wasn't challenging enough, we also had to scale Airflow up at the same time as we were basically 10xing our load with all this migration work. We had to ensure that there was zero downtime for all these pipelines. And probably the most challenging of all was actually training all of our Airflows to use, or all of our users to use Airflow. There's a lot of nuance between orchestrators, so even though conceptually things are similar, there are small changes or small differences, and that led to a lot of confusion with our users. They would expect a feature to work in one way, worked in a different way. So there's a lot of training sessions and other things we had to do with the larger data science teams at LinkedIn to ensure that they were aware of all the Airflow features. Despite all that, I am happy to report that we were able to complete that entire migration in just under a year. So now that you have some background, we'd like to discuss some of the lessons that we learned during different phases of our journey. Okay, so the first lesson we learned very early on was that multi-tenancy in Airflow is not free. It comes with a lot of challenges, and it took a lot of work to make this work properly for us. So the first challenge we had is, how do you land DAGs from 1,000+ repos into a single Airflow cluster? It's not easy, right? So our first approach here was the first thing we had to solve here was figure out, how do we want the DAG directory to look on Airflow? That is the main interface for Airflow for consuming DAGs. So we had to organize the DAGs in a very specific way, and we built a custom upload plugin that can handle uploads from these DAG repos and make sure they land in the right spot within the Airflow cluster to maintain this organization. Next, we had to handle other issues that come from this multi-DAG repo thing. For instance, how do you deal with DAG ID collisions or other parsing issues that only seem to occur when it lands on the production cluster? Sometimes in the DAG repo, we don't see this issue. Only when they all come together do we see the problem. So to handle this, we basically designed a set of policies and best practices on top of the Airflow best practices for LinkedIn. And then we enforced all of these through validations that we run at build time, at post-commit time, and at deployment time to ensure that all the DAG repositories are following these rules that we've put together. And ultimately, if somebody isn't following the rules, we'll reject that DAG at upload. So it sounds a little bit cumbersome, but what we ended up building was a completely one-click deployment system for our users. So all these validations are either baked into like a build plugin or baked into the upload. and the users don't see any of this. It's completely transparent. So unless there's a validation issue, all this runs behind the scenes, and the user doesn't even know it's running. And one other thing I'll touch on quickly for this distributed DAG repo, one other challenge is how do you handle task runtime dependency management? So every single DAG repo is going to have a different idea of what dependencies should be installed or what dependencies should be available to run my workload. It's a really big pain. So luckily for us, we're able to leverage that job executor service that I talked about earlier to kind of solve the problem for us. The job executor service can already handle dependency management and task isolation. So we dispatch any tasks that have specific runtime dependency needs. We actually dispatch through that service to provide us that isolation. I think there are a few other more Airflow native ways to handle that, but I won't get into that right now. Okay, so the next big challenge we had was how do we enable users to easily test their DAGs, right? They need to be able to test with only one repository. We don't want them to have to pull in all 1,000 repositories to do their testing, right? So here we're leveraging this Airflow sandbox that I talked about before. And the sandbox will basically automatically spin up Airflow inside of a pod. It'll do all the bootstrapping, all the variables, all the connections, everything is pre-set up. Any sort of authentication requirements or token generation is all done. And all this is done through a single CLI that a user runs, and it's up and running. They'll typically also specify a branch they want to work off of. The branch will get automatically pulled, and Airflow will automatically start parsing those DAGs. So as soon as they load up the UI in their sandbox, they'll see all their DAGs, and then they can just easily plug in their IDE as well. So basically, a way that a user will work is they'll plug in their IDE, modify the DAG. Those changes will reflect into the UI in the sandbox very quickly, typically in just a matter of seconds, and they can see the DAG change, and then they can go ahead and execute directly through the UI, same way they would do in production, press play, and it will dispatch a test job through that executor service that I showed before. And the last challenge that I kind of want to talk about was how do we provide centralized utilities? This is one that can be challenging because when they have this distributed DAG repo concept, different repos will look different. People will construct DAGs in different ways, and it becomes very challenging to provide these utilities. So to do this, we're really leveraging these best practices and stuff that I talked about before, and these policy enforcements. So we're trying to drive some amount of cohesion across all these DAG repos for the things that really matter. So driving this consistency is sort of a key piece in a number of these, as you can see, and that really enables us to provide these centralized utilities. And similarly, we're also driving these through our best practices. For example, to enable backfills, we have built a centralized backfill plugin, UI plugin that users can use. But it does require us to drive these Airflow best practices so users start using the logical date concepts inside of Airflow. Because coming from Azkaban, they're not aware of that. So driving these best practices, driving this cohesion was really one of our key takeaways from this lesson, and it helps us to drive multi-tenancy in Airflow. And then for the next lessons, I'll hand it over to Arthur.
Okay, so now that we've set up the foundations of Airflow, now the second problem we have to worry about is the actual migration. And this is exactly the second lesson, which is migrating user DAGs at our scale is really hard. When you have around 100,000 DAGs owned across hundreds of different teams, how can we migrate them with the least amount of time and zero side impact? Right? So as many of you in the summit has shared your perspective, we know engineers rewriting DAGs from one orchestrator to another is not possible. So the top priority for us is to provide enough tooling so that migration is really simple. Ideally, a pull request is generated with proper testing done, and the owner just need to verify the testing results and approve the PR. So how do we do it? As any responsible engineer in 2025, you'd say, let's use GenAI. And that's exactly what we did. So we created an agentic workflow that's capable of mass migrating Azkaban DAGs to Airflow. The workflow is capable of converting the source code from Groovy to Python. It will then map the existing Azkaban feature to Airflow ones. And since Groovy is a higher level DSL as compared to Python, it naturally will generate just a verbose amount of code, and therefore it needs major refactoring so that it's easier for the users to review all these codes. LLM turns out to be a great help here because with the latest reasoning model and everything, providing such refactoring capabilities almost out of the box. So after the code is generated, we run a set of tests, which I'll go into a bit more details. We'll feed these test results to LLM so that it fix all the known problems. And after the testing and fix loop is done, the workflow will generate the pull request with all the tests attached to it. And the user's job is simplified to review the PR, run some manual verification if they want, and then just ship it. So the happy path is easy, but we all know the drawbacks of GenAI, such as hallucination, generating non-deterministic results. And for our migration, we really can't afford it because that's just higher user migration if they were ended up manually doing all those efforts. This means we need extensive testing. And I'd like to highlight two important things that really helped us to get this workflow productionized. First is we leverage kind of the previously mentioned sandbox capability, where we embed one sandbox for each workflow so that the agent owns an Airflow environment for it to run validations, such as checking import errors, running the converted DAGs, and check DAG run results. The second one is how we make sure that the agent with sandbox doesn't actually do damage to production. In case the code written is bad, or it just ended up spending a bunch of compute resource. We made the decision to have agent run the DAG without actually calling the downstream services. So we intercepted all the downstream calls, and we captured the downstream calls using a call spec. And we can use these call specs later to do like a before-after comparison whenever the LLM does any code change. Then we capture the diff of the spec and then feed it back to the LLM for it to solve the bug that it created. So with proper testing, we can start to generate some pull requests, but debugging these failing workflow was really painful. Our AI workflow involves many, many steps, and especially when it runs a long fixing loop, it gets really complicated. So observability became really important, and this was early 2024. We really leveraged some of the recently announced open source tracing capability, adding our own custom monitoring to provide a rich trace into each workflow so that debugging is possible. Here's the high-level diagram for our migration workflow. You can see on the left side, we basically batch generate all the migration requests coming from Azkaban. All the AI workflows kind of runs in parallel. It will fetch metadata as well as the DAGs from previous orchestrator, and then prepare its own workspace where it spawns up the Airflow sandbox, and then start to do the conversion. And then after conversion, do all the testing. As I was mentioning previously, once all codes is converted, it continues to the next step to refactor all these code generated. After everything is tested, it will just publish a PR with all the test results put in there so that it's easy to reproduce by the users. With this workflow, we were able to bring down user involvement to the minimal amount and successfully completed the migration within a year. So now that we've migrated all these DAGs to Airflow, the last lesson I'd like to share is around scaling. So it's a continuing effort as we continue to see traffic growth. The first point is really to completely decouple compute from orchestration. We all know Airflow is capable of running some computes, but we made the decision to move all the computes out of Airflow to the downstream services. So that service can focus on optimizing computes, whereas Airflow primarily focuses on DAG management and task dispatching. Next top thing is to really scale with reliability, because any pipeline failures or delays are treated as incidents. Want to make sure that these infra errors are handled gracefully. So a few things here that we did is for finding the optimal control plane setup, we need fast load tests to figure out where's the bottleneck and what's the best configurations. We didn't see a prescribed way from open source, so we implemented our own load test tooling following the AIP 59. These load tests can basically be triggered easily from a CLI. It will mass generate DAGs with the structure of our preference. And then these test results will also come with a rich set of performance metrics for us to do post-analysis. For our internal observability, we use a mixture of out-of-the-box as well as custom control plane metrics, plus the important downstream metrics such as Kubernetes and DB, we just found it really important to manage these downstream latencies because any spikes, for example, in the Kubernetes latency can cause pipeline delays because we solely use Kubernetes executor. Lastly, we made the system they can recover under downstream failures or transient failures. Notably, these are DB connection issues or DAG file system instability. Open source doesn't really provide a out-of-the-box way to handle these, so we made sure these failures are not visible to the users. They're either auto-retried or being recovered gracefully. Lastly, since we have a huge number of DAGs, the UI just became really slow after some point. We really need to do a lot of performance enhancement to the UI to make sure it operates smoothly. A few things that we found really helpful is when you have a lot of DAGs and each of them has a lot of tags, the homepage just becomes not usable. The searching also became not usable. Recommendation is for those of you who haven't done this yet, don't create too many tags. And if you do need it, you would need some fixes into the web server to make sure the UI does filter out the tags that it does not need to load. Second thing is the access control metadata. This metadata can also grow huge when you have many DAGs and many ACL rules created. So we added simple caching in the web server end to optimize its performance so that UI loads faster and the DB load is reduced as well because a lot of complex joins are being avoided. So I'm going to stop here. These are all the important lessons that we learned that we want to share. It's overall been a thrilling journey, migrating the entire LinkedIn data pipelines to Airflow. And we hope you walk away with one or two useful things given our experiences. So that's all. Thank you.